I'm Anil Kumar. Here is the very first video on factorial notation and permutations. It will be foundation for organized counting. So it's very important to understand how to use factorial notation and permutations and how to evaluate numbers using this notation. Soon you will see its application in many questions where we are talking about arranging distinct objects in different ways and also finding probability for different kinds of events. In this particular video, we will see and understand what factorial notation is, how to evaluate factorials. We'll work with factorial expressions. We'll also see the connection between factorial and permutations, and also see how it helps in counting possibilities. We'll have a few examples to evaluate and express in NPR form. Now we'll have 5 excellent questions based on factorial. Some of them are really challenging questions. I'd like you to pause the video, copy these questions, try them out. And if you can really answer these questions, you can actually skip this video. Question number 1 here is to convert in factorial form 2 times 4 times 6 times 8 times 10 times 12 is what in factorial form. When I say factorial form, that's the notation we are going to use. N factorial, it means n times n minus 1 times n minus 2 times so on till times 2 times 1. Do you understand? So it's kind of multiplication of n numbers in order. So that is the factorial notation. NPR, which we are using for permutation, has a formula to evaluate where we write NPR as equals to n factorial divided by n minus r factorial, right? So we'll explore all this in few minutes from now. So once again, I'd like you to copy these questions and work them out. Question number 2 here is, prove that n factorial plus 1 is not divisible by any number between 2 and n. Excellent question. Question number 3, solve for n. So we have 3 different equations here. You need to solve for n. So that will give you a command on using factorial notation. Question number 4 here is justify that 0 factorial is equal to 1. And question number 5 is one of the most difficult. Find highest power of 2 that divides evenly into 100 factorial, right? So these are the 5 questions which we are going to discuss at the end. But let us first understand basics about the factorials. Factorial, as I said, is a product of series of consecutive integers. N factorial can be written as n times n minus 1 times n minus 2 times so on till 1. Or you could write it in the reverse order, 1 times 2 times 3 times so on till n. Now let us see how to evaluate these factorials. We'll also see how to use calculator to evaluate since these are very big numbers. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, right? So that is 6 factorial. So you can use calculator, of course, and without that also you can do this small number. 6 times 5 times 4 times 3 times 2 times 1 is equal to 720. Now in calculator we have factorial which can be used with shift. So we can say 6 shift and then press this button in my calculator to give you 6 factorial, and when you say equals to, you get 720. So that is how you could actually use calculator also to evaluate or calculate factorials. Now let's see the other example. Most of the time in the examples you could do without calculator. I have selected questions in that manner. So now what we will see is what is 11 factorial over 9 factorial. 11 factorial could be written as 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And 9 factorial can be written from here onwards, which is 9 times 8 times 7, 6, 5, 4, 3, 2, and 1. So whenever you write like this, you can now see a pattern, and now it becomes very clear that if it is 11 factorial over 9 factorial, then the 9 factorial part can get cancelled. Do you see that? We are left with only two terms, and 11 minus 9 is 2. Do you recognize that? So only two terms, 11 times 10. So we know what it is. It is 110. So we get this as equal to 110, correct? So that is how you could do it. Now let's practice with one more example, which is 10 factorial over 6 factorial by 4 factorial, right? Now this time, when I'm going to write 10 factorial, see how I write. I'll write 10 times 9 times 8 times 7 times 6. And since there is 6 factorial here, it's a good idea to just write this as 6 factorial. Perfect. As you saw last time, 9 factorial got cancelled. So we'll just write 6 factorial. No need to waste so much of time. And then we'll write 6 factorial and expand 4 factorial, which is 4 times 3 times 2 times 1. Now this dot will now be used since it saves time, and multiplication sign can confuse you with variable x also, correct? So it's a good idea to use dot. So we are going to use dot for multiplication. 6 factorial cancels. So we have 4 terms here. 10 minus 6 is 4. Very important to observe all this. 10, 9, 8, 7. That's it. 4 terms. Perfect. And so we have all this. Now we can simplify this. Well, 4 times 2 is 8. So 8 goes away. And 3 multiple 3 times is 9. So you see, without calculator also, you can calculate all this. And what you get here is 7 times 3, 21 times 10 is 210. Is that clear? Now 10 factorial is a very big number. So let's use the calculator to find what 10 factorial is. Just type in the number 10, shift, and then factorial sign equal to gives you that number, which is 3628800. So it is 3628800. So that is 10 factorial. Well, you will observe that the highest number you can go for is actually 69 factorial. You can find that answer, but 70 factorial will give you an error since it goes beyond the limit of most of the calculators. That's a good number to just to know, right? Okay, let's move on and see how to write factorial expressions now. Here we have factorial expressions. We need to convert the following products into factorial. 3 examples. I'd like you to pause the video, copy these 3, solve them, and then look into my suggestions. First is very simple, multiplication of 1, 2, 3, 4, 5, 6, and that could be written in short as 6 factorial, correct? So that is so simple. Okay, let's move on to the next one. And here we have n times n minus 1 times n plus 1. Now first thing is, let's arrange them in a particular order, writing the highest number first. So we have n plus 1 here, and then times n, and then times n minus 1. You must have realized by now that in all our examples, what is n? What is n? So n belongs to whole numbers, right? N belongs to whole numbers. That is what n is. Okay. Now, n plus 1 times n minus 1. If I use factorial, then it will go on and on till 1. How could I write this one? Okay. So the idea is we have only 3 terms here. Correct? We have only 3 terms here. We could write this as n plus 1 factorial, divided by whatever comes after this. Do you get an idea? So after this is n minus 2, so we say n minus 2 factorial. Does it make sense to you? So if I write like this, you can expand and check yourself whether this is the right way of writing the factorial expression or not, right? So from here, complications built in. Now part C is probably one of the most difficult questions to begin with, so that is a thinking question. How do you write 2 times, 4 times, 6 times, 8 times, 10 times, 12 in factorial notation? Now I'm going to introduce to you the term permutations and its link with factor notation. That's very huge and really helps us in counting principles, writing things in short, and also finding probability for many types of events. So here is the definition kind of. A permutation of n distinct items is an arrangement of all the items in a definite order, right? So let's kind of read it again. What is permutation? So we can say that a permutation of n distinct items is an arrangement of all the items in a definite order. That is what permutation is. We normally write this as npn. In this particular case, we are taking all the items. So the key word here to look into is n distinct items. So that is this n. And all the items is this n. Is that okay? That is what all the items, right? So n. Okay, so let's work on these 4 examples just to show you how permutation is linked with factorial. So first example here is, in how many ways can 4 students line up for a photograph? So that means we have 4 positions. So let's say this is first, second, third, fourth, and we have 4 students. So in the first position, any one of these 4 can come. So we have 4 options. In the second, once one person is there, we are left with 3, and then we have taken 2 are left, and then only 1 is left. And therefore the result is 4 times, 3 times, 2 times 1. So that is the answer for us, and this could be written as 4 factorial. So you see how in counting factorial comes into picture. So it's huge importance. Next question is, in how many different orders can 5 songs be placed? So that means there are 5 positions to play a song, right? So in the first case, there could be choice of 5, then 4, 3, 2, and 1, and so the result is 5 factorial. Correct? Find the number of ways you can arrange the letter of the words number. So number, let's say N-U-M-B-E-R. We have how many numbers here in number? 1, 2, 3, 4, 5, 6. So we have to arrange all the letters of this word. So out of these 6, we have choice of 6 here. Once we pick up 1, left with 5, then 4, 3, 2, and 1, right? So that is 6 factorial ways. And the last question here is, in how many ways can 7 books be arranged on a shelf? Well, 7 books means we have 7 positions, 1, 2, 3, 4, 5, 6, 7. And you could put any one of those 7, then you're left with 6, 5, 4, 3, 2, 1. And 7 factorial is your answer. In a different way, all these questions could be said, find the number of permutations of n distinct items in an arrangement of all the items in a definite order. So these are the orders in which you are arranging, and we say, well, it is npn, right? npn, which is equals to n factorial. So in the first case, we have 4 students to line up, so it is 4p4. In the second case, we have 4 songs to be played, 5 songs, so 5p5. And in the third case, the letters in the number are 6, so it is 6p6. Those words may or may not have any meaning, doesn't matter, but you can arrange them, right? And 7 books, all 7 to be arranged means 7p7. So you can see that if we take all the items together, then npn is same as n factorial. That is the result. Now n factorial is used so many times, it's a good idea to give it a name, permutations, right? So permutations is arrangement of all the items, but the items should be distinct. Well, it is not always arrangement of all the items. Let's be flexible. We can actually arrange some of those items, and that's where permutation becomes intricate, right? So now we'll talk about permutation general form. Now in general, we can say the number of permutation of R items taken from n distinct objects or n distinct items is NPR, and this is written as n factorial by n minus r factorial. Do you see that? So that becomes a general formula for permutation, and let's now answer similar questions which we asked last time, but this time we'll not take all of them together, right? We'll take only some of them. So question number 1 here is, in how many ways can president and vice president be chosen from a group of 6 council members? So we have 6 members, but we have only 2 positions. Do you see that? We have only 2 positions. Since we have only 2 positions, choice is 6 out of 6 council members. When you choose one out of those 6, you're left with 5. So the result is 6 times 5, which is 30. Now this could be written as total number was 6, permutation, you selected only 2, 6p2, correct? That is your answer. So you have choosing 2 from a group of 6, okay? And mathematically, you could write this as 6 factorial divided by 6 minus 2 factorial, correct? That means 6 factorial divided by 6 minus 2 is 4 factorial, and that really means it is 6 times 5 times 4 factorial divided by 4 factorial. 4 factorial, 4 factorial cancels out. You're left with 6 times 5, which is 30. It doesn't make sense. So I hope the formula also makes sense now. So we had in the beginning a few examples to write factorial notation in different ways. So that is its direct application. Is that clear? We have another example here which says how many 3 distinct really means digits not repeated, okay? So that means number 111 is not a valid number. All the digits should be different. So I could have read 3 different or 3 distinct. How many 3 distinct digit numbers can be formed using numbers 1 to 9? So basically now we have 9 numbers, but we have 3 positions. We have only 3 positions for us, and all should have different numbers. That is, we cannot repeat what has been taken once. So 1 to 9, I have 9 options for the first place. Once I place a number, I'm left with 8 and then with 7. That is my answer, which I could write as total is 9, 9p3. Now we can use calculator to calculate these values. So in my calculator, permutation is here with the shift key. 9p3, I can type in 9 shift permutation and then the number 3 equal to 504 is the answer, right? So use of calculator is very important for all these exercises. Now we have 2 practice questions for you. You need to evaluate what is 6p2 and what is 52p3, right? So let's do 6p2. 6p2 means 6 times 5. Just multiply 2 numbers. We just did this here, 6p2, right? 6 factorial by 6 minus 2 factorial using the formula. Effectively, it is 6 times 5, which is 30. Now, using this factorial notation is helpful. You can see that, right? So normally, when we are finding the number of combinations or permutations for, well, we'll introduce you to combination term later. Anyway, let's talk about permutations at present. So 6p2 really means that we have to select 2 from 6 distinct items. That's what it means. So we have 2 positions, so we get 6 times 5. Is that okay? Now that factorial notation is convenient way of writing and it's very useful. So that gives you a reason why we normally write NPR in this form. So the answer is clear. Now how to do 52p13? Now 52p13 you will be calculating in the game of cards where there are 52 cards in a pack and 13 are distributed. Okay, so that is 52 shift and here is NPR function and 13 equals 2. It gives you a very big number which is 3.94 times 10 to the power of 21, right? So anyway, so you expect very, very big numbers at times. So let me write this as 3.9542 times 10 to the power of 21. Is that okay? So that is the result of 52p13. Now here is the interesting question which says express 9 times 8 times 7 times 6 in the form of NPR. So you can try this question. 9 times 8 times 7 times 6 as NPR. The answer should be 9 is the highest number, right? So we are selecting out of 9 items. How many? 1, 2, 3, 4. So the answer for this should be 9p4. Is it okay? That should be the answer. But alternate way of doing this is kind of writing in this form and then doing it, right? So we could write this as, let me show you. We could write this as 9 factorial divided by, after 6 there is nothing. So it should have been 5 factorial. Is it okay? So I could write this as 9 factorial and I could write 5 as 9 minus what? I can write this as 9 minus 4 factorial and that is how I get 9p4. Do you get an idea? So normally you have to do in this fashion. So I hope the concept is absolutely clear as we move forward. Now we'll take up some thinking questions on factorial notation and permutations. Now here is our first question. It is a thinking question. We skipped it last time. Now I hope you have few concepts about notations or factorial notations rather. So I'd like you to pause the video and answer this question. It is convert in factorial form 2 times 4 times 6 times 8 times 10 times 12 is equal to what? So let me rewrite this. We are working for 2 times 4 times 6 times 8 times 10 times 12, right? Now 2 could be written as 2 times 1. Do you see that? And 4 could be written as 2 times 2. 6 could be written as 2 times 3. 8 could be written as 2 times 4. 10 could be written as 2 times 5. And 12 can be written as 2 times 6. Is that clear? So when we multiply, how many 2's do we get? So we get 1, 2, 3, 4, 5, 6, right? So we get 2 to the power of 6 and the other numbers left are 1 time, 2 time, 3 time, 4 time, 5 time, 6. So we have 1 time, 2 time, 3 time, 4 time, 5 times 6. Do you see that? So what we get here is 2 to the power of 6 times 6 factorial. 1, 2, 3, 4, 5, 6 could be written as 6 factorial. So that is how you could actually answer this question. So it's not a very easy question. You have to work with numbers and then get the result. You get an idea, right? So we have an extension of this question, which is the last question. What is the highest power of 2, which will be factor of 100 factorial? So think about that and it will have similar concept as we have solved question number 1. So I hope you find it very interesting. Question number 2 here is prove that n factorial plus 1 is not divisible by any number between 2 and n. Now that's again a very interesting question. Now what is n factorial? N factorial basically is n times n minus 1 times n minus 2 times so on till we do like 3 times 2 times 1, correct? Now when I write like this, what does it mean? That means that all these numbers 1 to n are factors of n factorial, right? So that means all numbers, I should say 2 to n, are factors of n factorial. Is that clear? Factor means when you multiply, you get that product. Perfect. Now, if I write n factorial plus 1, in that case, what happens? So that tells me that when I divide by numbers from 2 to n, 1 is the remainder. So 1 is the remainder when you divide n factorial by any number between 2 to n. Perfect. Since all those numbers are factors, remainder is 0 for them. If I add 1, then 1 is the remainder. Now, since 1 is the remainder, we know that n factorial plus 1 is not divisible by any number between 2 to n. Is that okay? Does it make sense to you? So try to get the concept. Concept is that n factorial is product of n times n minus 1 times n minus 2 and so on. So all these numbers are factors. If you divide n factorial by any of these numbers, remainder is 0. However, if I add 1, remainder is 1. So that number cannot be divided by all these numbers. So that is how we are going to prove it. So I hope you find it very interesting. Let's move on. This could be really interesting. Question number 3 here is solve for n. So these are equations involving factorial. I'd like you to pause the video, copy these questions and solve them. So first one here is, let me do it here, n factorial over n minus 2 factorial is equal to 90, right? So that basically means n times n minus 1 times n minus 2. We could write factorial. Now you know the trick. And we have n minus 2 factorial equals to 90, correct? So n minus 2 factorial, n minus 2 factorial cancel. What we get is a quadratic equation, n times n minus 1 equals to 90. Now it is all up to you. Once you get this quadratic equation, you can expand, get the quadratic equation, use quadratic formula, factor, do all, and get your answer. The other option is, whenever we are talking about factorial, we are talking about what? Remember this. We are talking about product of consecutive numbers. This is what we are interested in. Keep that in mind. So if you keep this in mind and there's a multiple choice question based on this, you know your answer. Your answer is product of two numbers, which is going to give you 90, and you know it is 9 and 10. Bigger number is 10, right? So n is equal to 10. You get an idea? So it is 10 times 9. So n is equals to 10. So that is your answer. So I hope the concept is clear. It is very important since that could be a question in multiple choice. In fact, all of them will be questions in multiple choice. Okay. Now let's look into the next one, which is 1 over 8 factorial plus 1 over 9 factorial equals to x over 10 factorial. So in this particular case, let me multiply each term by 10 factorial. So this was part A. Now let's do part B now. So what I'm doing here is I'm multiplying everything by 10 factorial. So I'm writing this as 10 factorial by 8 factorial plus 10 factorial by 9 factorial equals to 10 factorial by 10 factorial x. So the right side is 1, correct? And on the left side, it is 10 times, I could write this as 10 times 9, is it okay? Plus, this is just 10, 9 factorial cancel away, and we have this is equal to x. I hope that point is very clear. And that means what? 90 plus 10, which is 100. So we get our answer as 100. Is that clear to you? Right? So this is 90 plus 10 equals to x, and we get our answer as 100. Perfect. So I hope that is clear. So that is how you're going to solve it. So I'd like you to spend some more time and do similar questions. Next question here is n plus 1 factorial equals to 12 times n minus 1 factorial. Okay, so we'll do part C here. N plus 1 factorial could be written as n plus 1 times minus 1 will leave us with n times n minus 1. As soon as you get a similar term, just put factorial and do not write further. You need to understand these tricks. 12 times n minus 1 factorial. That's it. And now you just cancel n minus 1 factorial. What you're left with, again, a quadratic equation which says n plus 1 times n is equal to 12. You have to figure out two numbers. We are looking again for consecutive numbers. Remember this portion, right? Consecutive numbers which are going to give you 12. The numbers are 4 and 3, correct? So in this case, n is a smaller number, right? N plus 1 is a bigger number. So our answer is n equals to 3. Perfect. So that is the solution. So these are three very interesting examples on how to work with equations involving factorial notation. Perfect. And that is how you should be answering them. I hope you find them interesting. So let's move on and do question number 4 now. Now question number 4 is a communication question. It says justify that 0 factorial is equal to 1. Now this is very important to understand what is 0 factorial equals to, right? So 0 factorial is actually equal to 1. Normally when we are talking about factorials, we normally take n as greater than equal to 1, right? We normally avoid 0. But in any case, if you get to 0 factorial, you should remember that it is equal to 1. Now how do we justify? One way is using number of arrangements. As you have seen, we have used the term NPR, right? So we use the term NPN. So if we have 0 items, let's say we have nothing, right? If we have 0 items to arrange, then how many ways do we have? Well, there is always one way, null set, right? There's always one way, right? Which we also say null set at times. It's a very important concept. So there, 0 factorial has a lot of meaning, correct? So that one way of arranging 0 items is very, very useful concept. So this is from concept point of view. You could also see it from a different way. For example, let's go through the pattern ones. What is 4 factorial? Let's write down. What is 4 factorial equals to? 4 factorial is 4 times 3 times 2 times 1, which is 12 times 2 as 24. And what is 3 factorial equals to? 3 factorial is 3 times 2 times 1, which is 6, right? And what is 2 factorial equals to? 2 factorial is 2 times 1, which is just 2. And what is 1 factorial equals to 1, 1, right? So it is just 1. What should be 0 factorial? So you could do like this. So basically what we did here was that to get from 24 to 6, basically we divide by 4 because we are going to 3 factorial, right? So we divided by 4, and in this case we divide by the number 3, right? Number 3, and in this case we divide by number 2, and to get 1, right? And now we are going to divide this by number 1, and what do we get? 1 divided by 1 is 1. So that's another logic. You can say that 0 factorial is just 1, right? So there is nothing very concrete to say about it, but I hope that helps you to just understand that 0 factorial should be taken as 1. So we'll take 0 factorial as 1 without any reasons. It forms a base for us. Okay, let's move on, and here is the most difficult question of the whole exercise. Question number 5. Find highest power of 2 that divides evenly into 100. Factorial. So we have 100 factorial now, right? So 100 factorial could be written as 100 times 99 times 98 times 96 times, I'm just taking few terms here, so on, times, let's say we write here 6 times, okay, I should not have written 6, I will go further down, okay, anyway, so we just filled this up. So that is what 100 factorial is. We are looking for highest power of 2. Now the concept here is, as we did in our question number 1, right? So we say refer to question 1, right? It is kind of related. Anyway, so we see that there is one power of 2 here in these even numbers. I missed 97, okay? And I missed 97, and here we are supposed to have 95, okay? Anyway, so what we see here is that these numbers, alternate numbers, will be divisible by 2. Does make sense to you? Now, since we are looking for powers of 2, how many numbers will have power of 2? Well, we have 50 numbers, right? 50 numbers from 1 to 100, which are even, right? 50 numbers which are even. So that means they all will have power of 2. So I could actually, in a way, looking only for powers of 2, could take 2 to the power of 50, since there are 50 numbers. We are only looking for highest power of 2, right? So we are not evaluating everything, right? So we have 2 to the power of 50, and if I take those numbers, for this could be written as 2 times 50. Do you see that? 100 could be written as 2 times 50. 98 could be written as 2 times 49, and so on. So if I take those numbers, what do I get? And 96 could be written as 2 times 48, right? 2 times 48, correct? So if I take only those even numbers, I'm left with numbers 1, 2, 3, 4, and so on till 50. This is those even numbers, right? And then we will multiply this by the other odd numbers, which are like 99 times 97 times 95 times so on, times 3 times 1. Is it okay? So that is how we could write our expression. So we have divided this into 2 streams, even and odd kind of thing, and we factored this out kind of like this. Does make sense to you? Okay. Now let's look back into this list once again. This is all odd, right? So we'll forget about this list. It is all odd list. Is it okay? But here we have some even numbers. We have still some even numbers. Do you see that? How many are even here? Well, half of them are even. So we could do this as 2 to the power of 50 is already there. We have 2 to the power of 25. And if I select that list here again, those even numbers, then I get 1 times 2 times 3 times 4 times so on till 25. Is it okay? And from here I get another odd list of 1 time, 3 time, 5 time, the numbers which I did not select till 49. And we already have these numbers which is 99 times 97 so on till 1. Is it okay? We are only interested in powers of 2, so we are not evaluating that portion. This is all odd list. Is it okay? And this is mixed up. So we are always working with a list which is mixed up. It has few even numbers, as you can see. And that is the way we'll just go on and figure it out. So we have now 2 to the power of 50 times 2 to the power of 25. How many even number now? Well, half of 24, which is 2 to the power of 12. And if I do the same process, I have 24 here. Dividing 24 will give me 1 times 2 times 3 times 4 up to 12. Is it okay? And from here we get a list of other odd numbers. So we could just leave this for the time being. You understand, right? So we have 3 lists now. Okay. But looking into this power of 10, 2, powers of 2, we see still we have 6 numbers which are even, right? 6 even numbers in this list. Kind of 2, 4, 6, 12. Is that okay? So we could again write this as 2 to the power of 50 times 2 to the power of 25 times 2 to the power of 12 times 2 to the power of 6. Correct? Now we could again split this into even odd powers. So these which got divided, we guess 1 times 2 times so on till 6. Is it okay? And then we have another list which is 1 times 2 times, 3 times 5 till 11, right? Which were odd. And then other 2, right? So other 2. Anyway, we have gone so far. We are left with very few numbers to work with now. So we get 2, 4, 6. There are 3 numbers, 2, 4, 6. Okay. So we get 2 to the power of 50 times 2 to the power of 25 times 2 to the power of 12 times 2 to the power of 6. And that means 2, 4, 6 is 3, right? So we get 2 to the power of 3. And if I do that, I'm left with 2 divided by 2 is 1. 4 divided by 2 is 2. And 6 divided by 2 is 3. Plus the numbers 1, 3, 5 and all other lists, right? So all other lists. Does make sense to you? Is it going good? Now we have only 1 power of 2 left. So that is the 1 more power of 2. So we have 2 to the power of 50 plus 25 plus 12 plus 6 plus 3 plus 1 as our answer. Let's do this. So we have 50 plus 25 plus 12 plus 6 plus 3 plus 1 equals to 97. So we have this number as 2 to the power of 97 as our answer. Does it make sense to you? So that is how you could actually figure out the highest power of 2 that evenly divides into 100 factorial. So the exercise here is to keep on factoring out even numbers, dividing them by 2, generating a list of only odd numbers. So these are only pure odd, right? So these are all odd numbers. And then out of the mixed numbers, take out even numbers, and processes continue to figure out the answer. So we get 2 to the power of 97 as our answer. So the highest power of 2 that divides evenly into 100 is 97. Do you get an idea? So that's how we could do it. I hope you enjoyed this process of learning factorial notation and also going through some very interesting and challenging questions on factorial notation. You might see them in your test papers, competitive exams like IIT JEE, SAT, and so on. And it is going to be a great foundation for permutation, combinations, and probability to come. Feel free to write suggestions, your views, and if you like and subscribe my videos, that'll be great. Thanks a lot and all the best.